Hello everyone, welcome to Unify Study. In this video, I am going to discuss about two previous years question, GATE previous years question from direct cache mapping. I will discuss two types of questions so that you will be able to solve different so many questions, because this is our strategy, less is more. In that way, I am covering everything, less is more, because I am not going for the quantity, I am going for the quality. I will discuss different types of questions so that from one type so many question, maybe 100,000 question you can solve, and another type another 100 question you can solve. So watch this video till the end and subscribe to the channel and click the bell icon if you are new to this channel. This is about myself. I am Priyanka Chatterjee, UGC NET qualified with 99.46 percentile. And this is the Telegram channel Unify Study Computer Science. For any exam, for any competitive exam, if you are preparing for UGC NET, GATE or any other exam, this channel is for you, and in this channel I am sharing all the links, all the content and everything you will get. And this is the website, you can follow this website. Here I am uploading the content. Okay. Now come to the question. What is the question? This is a GATE previous years 2011 question. First question is, in our last video I have uploaded this question, but some confusion was there, that's why I am discussing this question again. Okay. An 8 KB direct map write back cache organized in multiple block in each size, that is 32 bytes. Means here it is given ki your size, that is your cache size. Here the size of the cache is 8 KB, means cache size is 8 KB, it is mentioned, and each size is block size. Here block size is mentioned, every block size is mentioned, 32 byte. Okay. And the processor generate 32 bit address, means this is total address is 32 bit. It is already mentioned here, means physical address is 32 bit. Don't be confused with this byte and bit. This is 32 bit address. Now the cache controller contains the tag information cache block comprising between the one valid bit and one modified bit. This is the extra bit. If in the question the extra bit is mentioned, then you have to add this extra bit with the tag bit. Means first you have to calculate the how many bits is required for tag, then you have to add the extra bit, whatever extra bit will be mentioned in the question. Okay. The as many bit as the minimum need, identify the memory block mapped the cache. What is the total size of the memory needed for the cache controller to store the metadata tags? Means it is asking about the size, what is the required size to store the tag. Means first you have to calculate the how many bits is required for the tag, and then you have to know that what are the number of lines in the cache memory, means what are the number of blocks or number of lines in the cache memory, and every blocks there are the tag. In our previous video we have discussed about the direct mapping. If you have not seen, please watch this video to clear your concept more. Okay. So see here, what are that is 8 KB, means 8 KB means what? That is 8 KB means 8 means 2 to the power just 1 minute, 8 means 2 to the power 3, and then there is KB, 1 KB means 2 to the power 10, right? So here it is 2 to the power 10 means 2 to the power 13, and then next one is 32 byte. 32 byte means what? That is 2 to the power 5, right? Now number of cache lines. What is the number of cache line? It will be cache size divided by block size. So cache size was 2 to the power 13 and block size was 2 to the power 5, means it will be 2 to the power 8, right? So 2 to the power 8 means 256, means here in your cache, if you think in your cache there are 256 lines, means it will be start from 0 and it will be end on 255, right? 256 lines are there. Now there will be in every line there will be the tag, right? So each tag, now each tag is defined that ki how many bits. You have to understand that how many bits are there in each tag, right? Our direct mapping, this is the structure of a direct mapping. We have discussed in our previous lecture that in a direct mapping, this is divided into three parts. What are the three parts? That is mapping, tag, one is tag, another is index, and another is block size or word size. Index means that is which block it will be, it will identify the block, right? So as there is 2 to the power 8 means 256 lines. So number of bits required is 8 bit. 8 bit will be required to point out, means where the block position, right? So here this is 8 bit, and the block or block size or bit, that is coming from this block size. What is the block size? Block size is 32 byte. So 2 to the power 5 means 5 bit is required here for the block, means here it will be 5 bit, right? So total was 32, and here 32 minus 8 plus 5, right? It will be 19. Here there was the confusion in previous lecture, so that's why I am clearing this concept here. So in that way this 19 is coming, clear? In that way this 19 is coming, because it is 5 bit block is coming from the block size. This is 2 to the power 5 means 5 bit, and this is the 8 bit is coming from the number of lines, means here how many blocks are there in the cache, how many lines are there in the cache, that are 2 to the power 8. So 2 to the power 8 means 8 line is required, 8 bit is required to represent, to map that, right? So it is 8 plus 5 means what will be the remaining, that is 19 bit. So 19 bit is for tag. Now in this question there was extra was mentioned, one valid bit and one modified bit. That's why you have to add this 1 plus 1. One is valid bit, one is modified bit. So 1 plus 1 plus 19, that is 21. Okay. So 21 number of lines are there, means 21 tags are there, and for each tag what is the size? What is the size it for the number of cache line, number of line, what are the number of line? That is 0 to 255, that is 256. 256 lines are there, and each tags require 21 bit. So 21 into 256, that is 5376 bit. Okay. So in that way the answer is coming 5376. This is the correct answer. 5376 is the correct answer for this question. I think your concept is clear now, right? If it is not clear or if there is any doubt, please let me know in the comment section below, and if it is clear to you, then also please let me know in the comment section below. Okay. Now next one, next question. The next question is, consider the machine consider the machine with a byte addressable main memory. So byte addressable main memory of 2 to the power 20 byte. Okay. Here it is 2 to the power 20 byte is mentioned, that is memory, means physical address it is mentioned 2 to the power 20 byte addressable. Okay. And the block size is 16 byte, box size given, that is 16 byte, and a direct map cache having 2 to the power 12 cache lines, means in your cache it is given how many lines are there, that is 2 to the power 12 lines. So from here you have to identify that how many bits will be there, right? How many bits will be there, that you have to identify, right? Let me clear this. So I will discuss everything. So I think now it will be clear to everyone that how to do the question. Okay. So just draw the what is the structure of the direct cache. The structure of the direct cache is, there will be the three part. One part will be the tag part, another part will be the cache offset part or index part, anything you can say, that is in index also you can say, or cache offset you can say, and here is word or byte, right? Word or byte. Clear? Now see here it is mentioned 2 to the power 20 byte, means what? That is 20 lines are there, 20 lines are there, that is 20 bit, right? This is 20 bit required, total is 20 bit. Now the block size is 16 byte, block size is 16 byte means how many? That is 2 to the power 4, that is 4 bit. 4 bit is required means word will be here 4 bit, right? It is done. Now the cache have 2 to the power 12 lines. 2 to the power 12 lines means 2 to the power 12 lines if they are in the cache. So to identify, to map the cache, there is 12 bit is required means here the index will be 12 bit, right? So total was 20 and here it was 12 and here it is 4 means it will be 20 minus 12 plus 4, that will be 4 bit. It will be 4 bit. Clearly the tag bit will be 4 bit. So totally it is divided into 3 part. This is 4 bit, this is 12 bit and this is 4 bit, right? Now here in the question it is given ki let address of 2 consecutive byte in the main memory is, what is the 2 consecutive byte in the main memory means here it is the main memory and the consecutive byte is mentioned here. One is E201F and it is in hexadecimal. Remember that this is mentioned in hexadecimal, okay? This is in hexadecimal. So you have to remember that and you have to clear your idea about that. That is hexadecimal address means what? Hexadecimal, if it is 5 bit hexadecimal number, then if you convert it in binary means this is the hexadecimal number E201F. So how many digits are there? 1, 2, 3, 4, 5. So every bit, every part of the hexadecimal is 4 bit. If you divide, if you convert in binary, then it will be total 20 bit binary number, right? But no need to convert in binary number. Why you will waste your time? There is the tricks to do it, right? Already you know this is all part is 4 bit, right? All part is 4 bit. You know that from the hexadecimal to binary. I think it is clear. If it is not clear, then learn the binary number system, okay? So now this is the tag bit means this 4 bit, this first 4 bit will be the tag bit. Clearly this is your tag bit, and this 3 bit means 4 into 3 means 12. This is your 12 bit, right? This 12 bit your cache offset. Clearly this is your cache offset, and this is your word part 4 bit. This 4 bit is your word part, right? Clearly, right? Now from here it is asking ki what are the tag and cache line address, means it is asking this tag part and this cache line offset. Tag part is first 4 bit. So first 4 bit means this is E. This is E, clearly this is E. So this one you can easily eliminate. F will be not there, and this here is 2, it will be not there. Cache line address, this will be definitely E, right? Now next one is coming ki a tag. This is tag is definitely E, and cache line address. Cache line address is this part, this 12 bit. Next 12 bit, that is 201. This is definitely 201 will be. So here from here it will be E, after that E20. No, this is wrong. Here only this is the correct answer, E201. This is the correct one. So easily you can do it in that way. No need to convert in binary, no need to do anything, just try to apply your knowledge, right? Of every bit of a hexadecimal address is always 4 bit, right? So 4 bit is first 4 bit is your tag, next 12 bit is your cache. So from here your E201, clearly this part is your tag E, and this 201 part is your cache line, right? So that's why the answer is coming here 201, and here is the explanation. If you want to know the explanation, this is the explanation I have written here. So I think from this 2 question your concept is clear. We have discussed 2 types of question from the direct cache mapping, and you will be able to solve so many questions, right? So if you like this video, please like, share and subscribe to the channel, and please let me know in the comment section below. And see you soon in the next video for the remaining part of the mapping. Okay, Have a good day. Bye bye. Thank you so much.